Every time you flip a light switch, something enormous has to happen first. Fuel has to burn, turbines have to spin. Electricity has to travel hundreds of miles through cables buried underground and strung across pylons before it reaches the wire inside your wall. Most people never think about that journey. They just flip the switch. But right now, deep inside the world's deepest gorge, a place so remote that most maps barely show it, where a river drops 2,000 meters in just 50 kilometers, China is building something that will change that journey forever. Not a power plant, not a solar farm, not a wind turbine, a dam, the largest dam in the history of human civilization. It will generate more electricity than the entire country of the United Kingdom uses in a full year. It will produce 3 times more power than the current world record holder, China's own Three Gorges Dam, which was already the largest in the world and took 15 years to build. It cost $170 billion, and construction began in July 2025. Now here's the part of this story most coverage completely misses, because this is not just an engineering project. Hundreds of millions of people live downstream, and they never got a vote. By the end of this video, you will understand not just what China built, but why it built it, what it means for every country in its shadow, and why the question of who controls this river may become one of the most dangerous disputes of the next decade. To understand the scale of what is being built, you first have to understand where it is being built. The Yarlung Tsangpo River begins its life in a glacier in the western Himalayas at an altitude of roughly 5,000 meters above sea level. That is higher than any peak in the Alps, higher than any mountain in the continental United States. The river flows east across the Tibetan Plateau, one of the most remote and least populated places on Earth, before reaching a point where the geography does something extraordinary. At a place called the Great Bend, the river wraps around a massive mountain called Namcha Barwa and drops 2,000 meters in altitude within just 50 kilometers. That is the equivalent of falling from the cruising altitude of a regional aircraft to sea level. In the distance it takes to drive from one end of a mid-sized city to the other. This canyon that the river carved through that descent is, by most measurements, the deepest canyon system on Earth. Deeper than the Grand Canyon in Arizona, deeper than the Colca Canyon in Peru, deeper than any other gorge on the planet. And at the bottom of that canyon, in a county called Meidog, one of the last counties in China to receive a paved road, as recently as 2013, China is now drilling 4 tunnels, each one 20 kilometers long, through the heart of a Himalayan mountain. Each tunnel will divert a portion of the Yarlung Tsangpo River away from its natural path and channel it through 5 cascading hydropower stations buried inside the mountain itself. The water does not simply fall over a dam wall and spin turbines on the way down. It travels through the mountain, losing altitude at every stage, spinning turbines at each of the 5 stations before emerging at the bottom with its energy fully extracted. Think about what that engineering actually means. 4 tunnels, each the length of 200 football fields, through a mountain in one of the most seismically active, most remote, most ecologically sensitive places on Earth. At altitudes where concrete behaves differently, where diesel engines lose 1/3 of their power in the thin air, where a single miscalculation in a seismic zone does not just damage a structure, it threatens everything downstream. And China started building it with a target completion date of 2033. Let us talk about what this dam will actually produce when it is finished. The current world record holder for hydroelectric power generation is the Three Gorges Dam, also in China on the Yangtze River, which took 15 years to build, displaced 1.4 million people, cost approximately $25 billion to build, and generates roughly 100 billion kilowatt hours of electricity per year. The Yarlung Tsangpo project is projected to generate 300 billion kilowatt hours per year, 3 times the Three Gorges, in one project. To make that number feel real, the United Kingdom, with 67 million people, a modern industrial economy, millions of homes, factories, hospitals, electric vehicles, and data centers, uses approximately that same amount of electricity every year. China is building a single dam that will generate enough electricity to power an entire nation the size of Britain, from one river, in one canyon, in one remote corner of Tibet. The project has an installed capacity of 60,000 megawatts, the largest dam in the United States, the Grand Coulee Dam in Washington State, which was itself a marvel of American engineering when it was completed in 1942, produces about 20,000 megawatts at peak capacity. The Yarlung Tsangpo project produces 3 times that. The Hoover Dam, the symbol of American industrial ambition, the dam that powered Las Vegas and irrigated the American Southwest. The dam every American school child learns about generates about 2,000 megawatts. The Yarlung Tsangpo project generates roughly 30 times that, 30 Hoover Dams worth of power, from one canyon in Tibet. The total cost of the project is approximately $170 billion, more than 4 times the cost of building the Three Gorges Dam. It is one of the most expensive single infrastructure projects in recorded history. China approved it in December 2024, started building it in July 2025. First turbines are planned for 2031, full commercial operations by 2033. So why is China building this? And why now? The honest answer is 3 problems arriving at the same time. In 2020 and 2021, rolling blackouts swept through parts of China. Factories shut down mid-production run. Freezers failed. Hospitals switched to backup power in the middle of working days. The world's largest economy had built itself on an energy foundation that could not keep up with its own growth. China's AI data centers, its 5G networks, its electric vehicle charging grids, all of them hungry for electricity that the grid was struggling to deliver. Coal still supplies over half of China's electricity, but China has committed to peak its carbon emissions by 2030. You cannot hit that target on coal. You need clean power that runs around the clock, not solar panels that go dark at night, not wind turbines that stop when the air goes still. And the rivers that were easy to dam have already been dammed. The last major untapped hydropower potential in the entire country sits in Tibet, on the Yarlung Tsangpo. The Yarlung Tsangpo is the last great river, and China has decided to harness it. But to understand why that decision is so much more complicated than an energy calculation, you need to understand what is happening inside that mountain. Here's the problem nobody mentions when they describe this project. Getting to Midog County is already an achievement on its own. The county was the last in China to receive a paved road. As recently as 2013, the only way to reach it was by foot, crossing mountain passes in weather that could kill an unprepared traveler. Today, there is a road, but it is a mountain road, subject to landslides, floods, and closures that can cut the county off from the outside world for weeks at a time. Into this place, China must transport thousands of tons of steel and concrete, turbine components so large they have to be manufactured in sections because no existing truck or tunnel could carry them whole, construction equipment capable of drilling through Himalayan granite, and tens of thousands of workers who need food, water, shelter, and medical care at altitudes where the air contains 40% less oxygen than at sea level. At high altitude, diesel engines lose roughly a third of their power output. Concrete cures differently. Workers suffer altitude sickness that can turn fatal within hours if untreated. The mountain itself is seismically active. This is earthquake country, where a major tremor is not a question of whether, but when. And the 4 20-kilometer tunnels at the heart of the project are unlike anything built before. Each tunnel must be precision bored through a mountain of Himalayan granite, one of the hardest rock formations on Earth, while maintaining alignment accurate enough to connect to the hydropower stations buried inside. A deviation of even a few degrees compounds over 20 kilometers into an alignment error that could make the entire tunnel useless. China's engineers are using tunnel boring machines that are custom designed for high altitude operation, machines that have been modified to function in environments where standard equipment cannot. Some sections require conventional drilling and blasting because the rock is too fractured for a boring machine to grip. Every meter gained in those sections is fought for individually. The project is also being built in the Yarlung Tsangpo Grand Canyon, recognized not just as Earth's deepest canyon, but as one of its most biodiverse ecosystems. Snow leopards, tigers, species of plants and animals found nowhere else on Earth. A landscape that remained essentially untouched by industrial civilization until construction trucks began arriving in 2025. Seismic risk assessments from geologists outside China have flagged the location as one of the most challenging on the planet for large-scale dam construction. A major earthquake during construction, or after the reservoirs begin to fill, could trigger landslides, dam failures, and downstream flooding affecting tens of millions of people in India and Bangladesh. China says its engineers have accounted for all of this. Its seismic designs, it says, meet the highest standards. Its environmental management plan will protect the ecosystem. Its turbines are designed to handle the most extreme geological conditions on Earth. That may all be true, but the project's full environmental impact assessment has not been made publicly available, and no independent international body has been permitted to verify the claims. Here's the part of this story that transforms a dam into something much more complicated. The Yarlung Tsangpo does not stay in China. Once it crosses into India, it becomes the Brahmaputra River, one of the most important waterways in South Asia. It flows through the Indian states of Arunachal Pradesh and Assam, irrigating farmland that feeds tens of millions of people, supporting fisheries that entire communities depend on, and feeding a delta system in Bangladesh that is home to over 100 million people. This river is not just a water source. For the communities along its banks in India and Bangladesh, it is an agricultural system, a food system, and an economic system all at once. Seasonal floods from the Brahmaputra replenish the soil. Fish populations cycle with the river's natural rhythms. The river's behavior, built over thousands of years, has shaped how entire civilizations organize themselves. China, sitting at the very top of the river as the upstream nation, now controls the flow. India has raised formal concerns. In 2025, Indian officials warned publicly that the dam could affect river flows into the Siang and Brahmaputra rivers, vital arteries for the northeastern states. India's own dam building plans in Arunachal Pradesh, long discussed and long delayed, suddenly gained new urgency as a strategic counterweight. Bangladesh, even further downstream and with even less leverage, has largely been left out of the conversation entirely. China's position is legally unambiguous. The Yarlung Tsangpo flows through its own territory. Under international law, it maintains what Beijing calls a legitimate right to develop the river within its borders. Chinese officials say the project is a run-of-river system, meaning it does not store large reservoirs that could be used to manipulate downstream flows. The water passes through and keeps moving. Critics are not so sure. Researchers who study China's operations on the Mekong River, another transboundary waterway where China built upstream dams, have documented patterns of wet season droughts and sudden irregular water releases that devastated downstream agriculture in Southeast Asia. The pattern on the Mekong, they argue, shows what happens when one country controls a river's headwaters with no binding international agreement governing how that control is exercised. The question for India and Bangladesh is whether the Yarlung Tsangpo becomes the Mekong of South Asia. And it is a question that has no international tribunal, no binding treaty, and no mechanism to resolve it other than diplomacy between countries that do not fully trust each other, situated on a border where tens of thousands of soldiers are currently deployed on both sides. The dam is 30 kilometers from China's disputed border with India. So let us go back to where this started. Every time you flip a light switch, something enormous has to happen first. In Tibet, in one of the deepest canyons on Earth, inside a mountain on the edge of the Himalayas, China is building the answer to that something. 4 tunnels, each 20 kilometers long, drilled through granite at altitudes where the air barely sustains life. 5 cascading power stations buried inside the mountain itself. A $170 billion bet placed on one river in one of the most remote places on Earth. When it is finished, if it is finished on schedule, and if the engineering holds, the Yarlung Tsangpo Dam will generate 300 billion kilowatt hours of electricity per year, triple the current world record, equivalent to the entire annual power consumption of the United Kingdom, from one canyon, in one remote corner of the world, 30 Hoover dams, in Tibet. And below it, downstream, over 130 million people in India and Bangladesh will wait to see what the dam does to the river they have built their lives around. China calls this the project of the century. Its engineers call it the dam of all dams. Its critics call it something else entirely. Here's the question I want you to answer in the comments, and I want your honest take, not the comfortable one. China is making a $170 billion bet on one canyon in Tibet to solve its energy crisis, hit its climate targets, and cement its position as the world's dominant infrastructure power, all at the same time, in a location where the seismic risks are real, the environmental costs are significant, and the geopolitical consequences for downstream nations are still being written. Is this the most ambitious and necessary engineering project ever built? Or is it the most reckless bet a government has ever made with someone else's water? Drop your answer below. Because this is a question that people who understand energy, people who understand geopolitics, and people who understand rivers are all answering differently right now. And if this video gave you something you did not know before, share it with one person who should be thinking about what is being built in Tibet right now. Because when this dam starts generating power in 2031, the world will have to decide whether it admires what China built or worries about what it controls. Subscribe so you do not miss what we cover next. Because the projects quietly reshaping the balance of power are not waiting for anyone to catch up.